This is Jack Jackson back. We're just going to pick up exactly where we left off last time. Let's back up just a teeny bit. We were talking about a triangular distribution 377, and just to review real fast, we start with that one. We want to find the graph and the formula for the PDF. It was a graph like this, so it goes from 3 to 7 is the important part, 0 outside of that. Going up from 3 to 7, x goes 3 to 7, then the graph is going straight up like that because the mode is here at 7. The length of the base of the triangle was 4. Turned out that gave us a height of 1/2, so that we get an area of 1. In general, the height is 2 over b minus a. 2 over the base is a height. That gives us 2 points here, one of which is an x-intercept. So we can use the x-intercept slope x-intercept form of a line to make an equation of that line pretty easily. And so it turned out to be 1/8 times x minus 3. How do we get 1/8? That's just the slope here. And the slope we find as we went up 1/2 and we went to the right 4. So that is 0.5 divided by 4 is in fraction form, and you want it in fraction form is 1/8. So the PDF formula is PDF of x equals 1/8 times parentheses x minus 3. That works from 3 to 7, 0 otherwise. So I went over that a little bit more slowly at the end of the last video. So let's pick up there by putting it in our calculator, and we want to put it in our calculator only going from 3 to 7 when we graph, but you can ignore the 0 part and just let y1 equal 1/8 times x minus 3. Just be sure you only graph from 3 to 7. So that kind of brings us to this point now that you have that in. So draw this by hand or in a calculator. 1/8 times x minus 3. You got an idea what that looks like. You have more importantly, we have a formula. Why do we need formulas? Well, when we're trying to find probabilities, something like we're finding an area like this, we need to find the height. And how do we find that height? Well, that's where we need the formula for the PDF, because it's just PDF of whatever that x value is below that we want to find the height at. So I've got 4 problems here. I'd like you to do these and then come back and check your answers with the video as we go along. So first of all, I want you to find these probabilities. I want you to also shade them as areas under the PDF graph. I'm going to ask you to pause at each one, work it out, and then come back. So first, let's do the probability that x is less than 4. Press pause now. Well, hopefully you realize that the probability that x is less than 4 is really between 3 and 4, this area of this triangle. The base has length 4 minus 3, which is 1, so that's just 1 for the base. The height is PDF of 4. PDF of 4 is plug in that 4 in this formula for x. So it's 1/8 times 4 minus 3. 4 minus 3 is 1 times 1/8 is 1/8. So the height is 1/8. By the way, 1/8 is 0.125, so that looks about right on the grid here once I put it on a nice Graphmatica graph where the grid can be seen. So that's 1/2 times base times height. That's 1/2 times 1 times 1/8 is 1/16, which is 0.0625. So that area is 1/16 of the total area. The probability that x is less than 4 is really the same as the probability that x is between 3 and 4, because you can't have anything less than 3 that has any probability. So that is 1/16 for that probability, 6.25%. All right, how about the probability that x is greater than 4? Figure that one out. Press pause, come back when you have it worked out. Well, since we just worked the last one out, this should be pretty easy. The region we're finding the area of is shaded there, which is actually a right trapezoid. But if you notice, it's the total big triangle area minus the unshaded part there. So it's just 1 minus the probability that x is less than 4. And as we just figured out before, the height there is 1/8 and the base is 1. So that area is 1/2 times 1 times 1/8. is 1/16. We just figured it out. So 1 minus that will be the part that we have shaded here, which is 15/16. In decimal form, that's 0.9375. Again, why do we need the PDF formula? We need it to figure out this height right here. Because it's just PDF of 4. All right, you do another one here. What's the probability that x is greater than 5? Figure that out. Also shade it to illustrate it. Come back when you're done. Press pause. Well, once again, we're looking at a trapezoidal shape like this to the right of 5. And so we see that graphed. The base then is just 5 minus 3, which is 2. The height is the PDF of 5. Plug 5 in that formula right here for x. 5 minus 3 is 2 times 1/8 is 1/4. So that height is 1/4. Look across, yeah, that's 0.25. That agrees. Base here is 2. So the area is 1/2 the base times the height. That's 1/2 times 2 times 1/4 is 1/4. What's that the area of? That's the area of the unshaded region. So the shaded region, remember, is the area of the big triangle, which is 1, minus this little unshaded triangle. So that is 1 minus 1/4, which is 3/4, or 0.75, or 75%. All right, let's do another one. What's the probability that x is between 4 and 6? Go ahead and work this one out. Come back when you're ready. Press pause now. Okay, so this time we end up with this area shaded between 4 and 6 here on the x. That kind of gives us the x-axis for the bottom. X equals 6 on this side, x equals 4 on this side, and the top is the PDF curve. All right, which in this case is a straight line. So that's just a right trapezoid. But again, we can find it by doing triangles. We can do the bigger triangle here, do its area minus the smaller area of the triangle, the unshaded one here. So for the bigger triangle, it's 1/2 base times height. The base goes from 3 to 6, which is 6 minus 3, which is a distance of 3. So 3 for the base. The height is the PDF above 6. So go into this formula, here it is in the corner, and plug in 6. 6 minus 3 is 3, times 1/8 is 3/8, so it's 3/8 tall. So that area is 1/2 times 3 times 3/8, that is 9/16. All right, so then how about this little unshaded part? That's the part we have to subtract off. Well, the base goes from 3 to 4, so that's a base of 1. The height goes from here up to here. Well, that's just the PDF of 4. So plug in 4 in this formula. 4 minus 3 is 1 times 1/8 is 1/8. So this is just 1/8 tall. Okay, and so the area of that triangle is 1/2 times 1 times 1/8, which is 1/16. 9/16 minus 1/16 is 8/16, which reduces to 1/2, or 0.5. All right, let's switch gears and try another one. Okay, what's the formula of the PDF for this distribution? And draw the graph. This is x is triangular, 2, 12, 2. See if you can work this out. Press pause, come back when you have it. Well, this is piecewise defined function where PDF is 0 outside of 2, 12. So it looks something like this graph. 0 to the left of 2. Out here, the unimportant part there. The other unimportant part is to the right of 12, where it's also 0. So it's on the x-axis, both those places. And inside, between 2 and 12, it's a linear function. And the mode is at 2 this time, which means the highest point is on the left side, which means it's a decreasing linear. So it's a negative slope linear equation. Okay, so what's the height right here? Well, we know the total area of that triangle there is 1. The base is 2 to 12. The base is 10. Okay, so 1/2 times 10 is 5. So 5 times the height is 1. The height is 1/5, or 2/10. 2 over b minus a, 2/10, it's 1/5. So the height is 1/5, or 0.2, and there's the height. So we know it goes to the point 2, 1/5 right there at the top. It goes from there down to the point 12, 0. We can use that to find our line. Okay, if you haven't done it already, stop this and figure out what the slope would be for that line. Remember, it's going to be a positive or negative number. Yeah, negative number, because this is decreasing. Okay, so notice what we have here is 2, 1/5, 12, 0. Just do the 2 points to find the slope. Let's see, 0 minus 1/5 means you went down 1/5, so it's negative 1/5 or negative 0.2 for the delta y. Delta x is 12 minus 2 is 10, so it goes to the right 10. So if this is the first point, this is the second one. We're going to the right 10 and down 1/5, so that works out to be negative 0.02 or negative 1/50th. 1 over 50, negative 1 over 50. Now the x-intercept is 12, 0, so we can have, it has the formula slope times x minus x-intercept. So that's negative 1/50th times parentheses x minus 12. That's the slope x-intercept form of that line. And so our formula is PDF of x equals negative 1/50th times x minus 12. X minus 12 is in parentheses. That works for x's from 2 to 12. It's 0 everywhere else. Now if you're going to graph it on your calculator, just let y1 equal this function, but be sure you only graph from between 2 and 12 on x. All right, so from the graph, illustrate the following probability and compute it. What's the probability that x is greater than 9? Press pause, work it out. Well, hopefully what you came up with is you ended up shading an area that looks like this. The base of that little triangle then, the shaded area, is our probability that we're looking for. It goes from 9 up to 12, so that's 12 minus 9 is 3 for the base. The height of the curve is the PDF of 9. Okay, so PDF of 9 means plug 9 in this formula. Let's see, let's work that out. 9 minus 12, that's negative 3 times negative 1/50th is 3/50ths. Okay, so what the area then is 1/2 base times height. That's 1/2 times 3 times 3/50ths. That's 9/100ths. In other words, 0.09 or 9%. All right, your turn to do another one. What is the probability that x is less than 5? Once again, you need to pause the video and work through these. It's one thing to watch me do them on the slides here. It's a completely different thing to be sure you can do them yourself. So it's important that you try these things yourself. You should be able to work this out. Press pause, come back when you're ready. Well, hopefully you came up with a shaded region like that we're finding the area of, and that is our probability that we're looking for. You can nicely see that as an area shaded to the left of the 5, 5 being the boundary point right here on the right edge. So everything to the left of that between the curve and the x-axis is shaded. That's a right trapezoid in this case. But it's going to be easier to find the area of this big triangle, which we know is 1, minus the area of this unshaded triangle here. So it's just 1 minus the area of the unshaded part. All right, well, the base of that unshaded part goes from 5 to 12, so that's a distance of 7. 12 minus 5, 7 for the base. And then the height is the PDF of 5. So that's why we needed this formula, is to find the heights like this. So just plug in 5 here. 5 minus 12, that's negative 7 times negative 1/50th is positive 7/50ths. So the area of that triangle there is 1/2 times base times height. That's 1/2 times 7 times 7/50ths. That's 49/100ths. 1 minus that is 51/100ths. So the part that is shaded is just slightly bigger than the part that's not shaded at 51/100ths or 0.51 or 51%. All right, here's another one for you to do. Same function, same graph. Shade the part that's the probability that we need here and calculate it. Press pause now. We're trying to do the probability that x is greater than 7 here. So when you look at this, this is a right triangle, okay? and the base is 12 minus 7, which is 5. The height is the PDF of 7, which is 7 minus 12. That's negative 5. And so negative 5 times negative 150 is positive 5/50. That reduces to 1/10. So the height is 1/10. So the area is 1/2 times base times height. That's 1/2 times 5 times 1/10, which is 1/4 or 0.25 or 25%. Okay. Okay, the next one is the probability that x is between 4 and 6. Okay, once again, illustrate the probability and calculate it. Come back when you got an answer. Press pause now. So here, once again, we get a shaded trapezoid here, and that's the area we want to find. Again, you can find it pretty easily. It's just subtracting two triangles. So I didn't put the marks on it down here to mark it, but the big triangle here goes from 4 to 12. So that's a base of 8 right there, 12 minus 4, and a height of PDF of 4. So you just plug in 4 to find the height here. Looking at this, it looks like it's about 0.16. Let's see if we can figure that out, what it is exactly. Put in 4. 4 minus 12, that's negative 8 times negative 1/50. That's positive 8/50, which is exactly 0.16. 1600ths, 8/50, 4/25 is another way to say that. Reduced fraction. So I'm just going to use reduced fraction 4/25. 1/2 times 8 times 4/25. Let's see, a half of 4 is 2 times the 8 is 16, and the bottom is 25. So that's 16/25. Now let's see, what is that? That's the area going all the way from 4 up to 12. So a big triangle there. And then we're going to subtract off a smaller unshaded triangle right here. It has a base going from 6 to 12, so that's a length of 6 right there. And its height is PDF of 6. Put the 6 in here in place of x. That'll give you the height of the curve right here. It looks like it's 0.12. Let's see if that works out. Let's see, 6 minus 12 is negative 6 times negative 1/50 is 6/50, which is 3/25. And that is 0.12. That's 1200ths. All right, so working this out, half of 6 is 3 times 3 is 9 on the numerator, and you got 25 on the denominator. So it's 16/25 is the area of the bigger triangle. The area of the smaller triangle is 9/25. Subtract, and we get 7/25, which is the shaded region, which is 0.28 or 28%.